Hello and welcome. This is a lesson on Chapter 1, Section 2, Analyzing Graphs of Functions, Part C. It's our third and final lesson of this section. We're going to be talking about finding the x and y intercepts of nonlinear equations, as well as determining if a function is even or odd. We've kind of already done all of these, but we're introducing new words, even and odd. So to find an intercept, and specifically the x-intercept, first off, it is where the graph crosses the x-axis, and it's just really easy by replacing y with 0. So how do I find it? We're going to just say, well, set y equal to 0, and then we're going to solve for x. And just as a visual representation, again, if you have some sort of graph that kind of looks like this, we can find these points by setting y equal to 0, or the whole function equal to 0, and then solving that, either factoring quadratic formula, complete the square, or any of those. So another one is your y-intercept, which is where it crosses the y-axis, and it's where x is 0, so you just substitute in x is 0 and then solve for y, which very similar will be where it crosses something like this. So if it crosses this axis, this is clearly not a function because it doesn't pass the vertical line test, but they are useful sometimes to have things that look like that, and we would have four values here where we cross that y-axis. So to do this rational function, it's not a polynomial or anything, it's two polynomials over each other, which is a rational function. We're going to find both the x and y-intercepts. Remember the y-intercept, plug in 0 for x, and then that's the easy one. And this one gets a little bit more difficult, but not too bad. So the first step is, well, we have y equals 81 minus x squared over 8 plus x squared, which again, we're plugging in 0 for that value of x, which then therefore it is 0 there. So my y-intercept is 81 minus 0, or 81, and 8 plus 0, which is just 8. So my y-intercept very nicely is just 81 over 8, because those go away. Now the other one is a tad more difficult, but not too bad. We just say 0 is our y value, so whatever y was, you put it at 0 and set it equal to that. Rational functions are very nice in the fact that we don't really care about the denominator, because we can't have this equal to 0, so we only really care about the numerator. So this kind of cancels out, or if you think about it, we take this and multiply it over to the other side, which 0 times this is nothing. So therefore, we have just 0 is equal to 81 minus x squared. We're only really caring about that numerator. And then what we do is we add the x squared to the both sides, and then we can square root to get that x is both the positive and negative square root of 81, or it's going to be negative 9 and positive 9 for my two answers for my x-intercepts. So another example here where it is a polynomial. If you rearrange it, you notice that you can put y on the other side or put x squared and negative 9 on the other side. And I just substitute in x is 0 right away. So therefore, we just get 0 squared, or 0 plus y minus 9 is equal to 0. So again, this 0 squared, I'm plugging in there, and it's just 0. So then we just solve for this, where we just add the 9 to the other side, so that what we get is y is 9. So very easily, our y-intercept is just 9. Now, my x-intercept, when I plug in y, is 0. Very similar. Well, we have x squared plus 0, and then minus 9 is 0. Now, this is just 0 here, and we just have to add that 9 to the other side. So then we just get x squared is 9. And then, very similar to the other slide, we just square up both sides to get positive and negative square root of 9, or my answer is negative 3 and positive 3. So our last thing of this lesson is both even and odd functions. What are they? Well, we've already talked about them, we just haven't defined them. So an even function is going to be where it's symmetric with respect to the y-axis. So we've talked about, and we've done that before, the simplest thing is saying, well, we can substitute in x and negative x into the function, and if they're the same, then they are going to be even. So the easiest way to do that is if I substitute in negative x into the original function, and that is identical to my original function f of x, then this will tell me that this is an even function. Very similar, an odd function, this will be called odd if it's symmetric with respect to the origin, meaning it has that rotational or 180-degree symmetry, which in this case we're going to have to substitute in negative x into the function, and then it has to be equal to the opposite of the function, or negative y. So this is like negative y, and this was saying x is negative x and y is negative y, same thing. We're going to walk through this, and this having the same thing will make sure it will be odd function. That'll be that rotational symmetry or symmetry with respect to the origin. So let's do an example of just looking at the graphs like before. Does it have symmetry over the y-axis, or does it have symmetry with respect to the origin? So even is if we can flip it over the y-axis and it will reflect it and it's identical, and if I could flip it upside down and it's the same thing, that would be origin, or that would be odd. So first thing is, let's check if it's y-axis symmetry, and if I go ahead and draw a vertical line, clearly this does not reflect over to the other side. So like if I pick this point here, there is not a point over here on the graph matching it perfectly, so therefore it cannot be even. Now is it odd? So if I rotate this whole diagram, will it be identical if I completely flip it upside down? So let's go ahead and do that. So let's see, well, if you look at that, this function is starting from the bottom left and going to the top right, left to right, bottom left to top right, bottom left to top right. It was doing that, but notice how it was moved over to the left on that one. So let's go back here, go over here. This was actually moved over to the right one. So it's not identical. It was actually shifted one to the right versus one to the left. So we cannot say that is odd either because it was shifted over. So that is neither of them. This next one, where again we look here, it's not even, it doesn't reflect. And then it's starting from the bottom left to the top right again, and it's not shifted at all. So let's just double check that it is odd. Bottom left to top right doesn't shift at all, so we're good here. So that one will be an odd function. So example 4 is not giving you the graph. This is where we'll actually prove that it is odd or even. The graph, it's sometimes hard to justify because you don't fully for sure know. It looks like it's odd, it looks like it's even, but is it really? Because the graph could be a little bit different, but you cannot tell sometimes. So let's go ahead and prove it using math. And this is the way you're going to have to do it in your homework or on your test or any quiz. So how do I do that? The first thing to do is it going to be symmetric over the y-axis? So does this original function equal if I substitute in negative x? So to figure out if it is in fact even, so let's just try to see if it's even. What we do is we're going to say g of, we're going to plug in this negative x here, and then what we're going to do is 2 times, well, again, we're plugging in that negative x. Is this identical to this? If it is, it will be an even function. So let's try that out. So is it even? So we have g of negative x is equal to, well, if we have negative x to the 5th, that's 5 negatives, and it still remains negative. So it's negative 2x to the 5th. Notice how this is not that. Therefore, it is not even. Nope, not at all. Now, an odd function will have to be if this value is equal to the opposite of all of this. So we're going to do our next step of being like, hey, we're going to do the opposite of g of x, whatever that is. So we're going to take all of g of x, which was 2x to the 5th, and put the opposite symbol in front of it. So if this was more than one term, we definitely need the parentheses because it's going to make and change the sign. So just like up here, it'll be the opposite of this, opposite of that. We'll talk more on when we get there. So if we look at that, this answer here, the opposite of g of x is equal to the opposite of 2x to the 5th. Now, that is important because this value, g of negative x, and the opposite of g of x are the same. If these are the same, that's an arrow. If these are the same, which they are, this means it's an odd function. So this is an odd function, which means it has that rotational symmetry. So let's go ahead and try another one here with h of x. So I'm going to move this over. So again, if I want even, we're going to plug in negative x. So we're going to do h of negative x is equal to negative 2 times negative x to the fourth plus 7 times negative x to the second. So if I plug in negative x for all of that, we get h of negative x is just negative 2x to the fourth. Again, it's an even power, so we have 4 negatives, so this goes and turns into x to the fourth. And the negative in front stays there because that would be the 5th negative in this whole group, or that term. And then this negative x squared is negative x times negative x, which turns into positive x squared. So we're left with plus 7x squared. Notice that this right here is the same as this right here. Those are the same. If those are the same, it is in fact even. Now, it can't be both. And there's only one exception, and I can say except when f of x is by chance 0. The trivial case. So that is the only time it could ever be both, because it's nothing and it doesn't have a graph or anything, but it can't be both even and odd at the same time. So please just try this one on your own. Pause it. I would want you to think through the justification and do the math for these ones, but I'm not going to do that. I'm just going to write down the answers in just a moment, so pause it and try it. So hopefully you tried it, you got odd. This is neither because it's shifted. This one, if you flip it upside down, it's good. This one's neither because it has a odd and an even power, which will not allow us to have either of them, honestly. And this is going to be odd because it does just have that odd power and nothing else. So our very, very last question here, example 5, is actually 3 examples. It's the same setup though. So if I'm going to look right here, I want to look at this and see if I can make the same thing. So if I want it to be even, I'm going to do f of negative x, so plug in a negative x. So then we're like negative x squared, absolute value of negative x plus 4. Now if you think about that, that is equal to x squared. And an absolute value, it doesn't matter if it's positive or negative, it's still the same thing. So we can rewrite that as this. And notice how this and this are the same, therefore it will be an even function. Now if I try for this next one, g of negative x, we substitute that in, we get 1 over x, negative x plus 3. That is not the same as this, so it's not going to be even. Now if I do the opposite of g of x, this is equal to the negative of 1 over x plus 3. Now this is where it gets tricky. Notice how I have a negative on the denominator. So I'm going to move this negative down here, but it doesn't just go to the x. You actually have to write it like so. It's going to all of the bottom, not just the x. So it's 1 over the opposite of x plus 3, which is in fact equal to 1 over minus x minus 3. Therefore, it's neither odd nor is it even. So we are going to put neither. The last one here is if we do h of negative x, we plug that in, we get the third root of 7 times negative x, which the nice thing is if it's a third root, fifth root, whatever, you can actually pull out the negative, and we get the third root of negative third root of 7x. Now, let me give me some more room over here. And then if we do that same thing, the opposite of h of x is actually just equal to the opposite of the third root of 7x, where therefore it is an odd because those are identical. So please try this one on your own. Pause it. I'll have an answer shortly. So you should get even, neither, and even.